Assalamu alaikum friends, I hope you're doing fine. Well, in today's video we will be again doing the question solving technique on the EES software. As in previous video of EES, I did the problem solving of steam power plant, and in today's video I will be solving a problem related to the ocean thermal energy conversion, also known as OTEC. As in this system there is difference of temperatures of seawater, and using that cooler and warmer shallow water, we drive our heat engine to produce useful work. So we will solve a problem of this system. So this is the question. As the ocean thermal energy conversion cycle, in which ammonia is the working fluid and the power output of this system is 150 megawatts, and it is also converted into British thermal units, which is 14,500 British thermal units per second, and the boiler is generating and saturated ammonia at 70.5 Fahrenheit, and then it is into and the temperature of the saturated liquid state is given as 50.5 Fahrenheit, which is in the condenser. We have also given the isentropic efficiency of the turbine, which is 80%. The things which we need to calculate are ammonia mass flow rate and thermal efficiency of the overall power plant. Well, this is the given data, as we have two temperature values, the isentropic efficiency of the turbine, and the net power output. Well, the things which we need to find are the properties at all four states, which is enthalpy and entropy. We have to also calculate the temperature and pressure on the states which is not given, and we also, as we have given the isentropic efficiency of the turbine, which is 80%, so we have to calculate the actual enthalpy and isentropic enthalpy at that turbine outlet. As asked in the question, we have to also calculate the mass flow rate of the ammonia and the overall efficiency of the system. So we start solving our problem in the software. After opening the software, first of all we have to convert the units, going into options, and in unit system we will just from SI to English unit system, and then we press OK. Okay, so let's start solving. First of all, we will define this as stage 1, and then after we will write the things which we are given, which is temperature T1, which is 70.5, and write it unit as Fahrenheit, and paste it. Okay. We will also write the quality, as it is in steam, so the x1, which will be 1. Then first we will calculate the enthalpy at this stage, so we will write as h1 is equals to enthalpy and bracket ammonia, and as we are given the temperature and quality x, so we will write as t is equals to t1 and x is equals to x1. Okay, bracket close, and we will check the equation, though no errors, so we'll calculate it, and here comes the enthalpy. We also the units are also mentioned in it. Now we calculate the entropy at this stage. We will S1 is equals to entropy and ammonia. We will mention the temperature is equals to T1 and enthalpy, which we have calculated as H1. Also check the equation, no errors. Okay, calculate. Here comes the S1 entropy. We will also calculate the pressure at this stage. Pressure P1 is equals to pressure and ammonia bracket T1 and H equals to H1. Okay, now we calculate it. Here's come the pressure 130 psi. Now we will go to the stage 2. Now as it is isentropic, so the entropy will be same of the stage 1 and stage 2, so S2 equals to S1, and temperature is as given, it is 50.5 Fahrenheit. We will also mention its unit F and paste. Okay, we will calculate the enthalpy at this point as S2 equals to enthalpy, and after that we will write the ammonia. We will mention the temperature at this point, T is equals to T2 and S is equals to S2. Okay, we will calculate it. Here's come the H2 as 617. As is it is isentropic, so we will add S, and as we have given the efficiency as 80%, so eta is equal to 0.8, and we will calculate the actual enthalpy. So eta is equal to H1 minus H2 divided by H1 minus H2S, which we have calculated. So we will get the H2 value from here as we solve it. So you get that H2 is equal to 620.9. We will also mention this stage as calculating the actual enthalpy. Sorry, I'm slow typing. Okay, now we will go to the stage 3. We will write it as at stage 3. Okay, so at this point it is back into the saturated liquid state, so quality will be 0, x2 is equal to 0, and the temperature value will be also be same as of T2. So we'll calculate the enthalpy as H3 is equal to enthalpy ammonia, and quality is equal to x2, and temperature is equal to T2. We will also calculate the entropy. S3 is equals to entropy, and in bracket we will write ammonia, comma, and we will mention the temperature as T2 and enthalpy as H3. Okay, we will also calculate the pressure. pressure, we have to find the pressure, and P3 is equals to pressure bracket ammonia, and we will use the temperature T2 and the enthalpy as H3. We also calculate the specific volume, so V3 is equals to volume, and ammonia, as it is ammonia, temperature is equals to T2 and enthalpy is equals to H3. Okay, now we will calculate all these four things. Okay, so here comes the H3, S3, P3 and V3. You see all these values, V3. Okay, with the units. Now we will go to the stage 4. We will write it at stage 4. Now at this stage, entropy will be same as it is isentropic system, so S3 will be same as S4, and as it is going back to the stage 1, so the pressure will be also same for this stage, P1 and equals to P4. Now we have to calculate the temperature at this stage, so we will use these two terms of pressure and entropy. Calculate the temperature as temperature bracket ammonia, and we will write it as S is equals to S4 and P is equals to P4. Okay. Here you get the T4 is equal to 50.54. We also calculate the enthalpy. H4 is equals to enthalpy. Enthalpy is equals to ammonia, and we will use this temperature value which we have calculated. So T will be and T is equals to T4. Okay, so here comes the H4, which is 106.7 British thermal units per pound. Okay, we have calculated all the four stages properties of enthalpy, and now the things which are asked are the mass flow rate. So we will calculate the mass flow rate as given in the system that the power output of the system is 150 megawatts, so we will convert it into British thermal units per second, which is 142500, and we will also mention the unit of it, British thermal unit per second. Bracket close, and we will now use the formula for the mass flow rate. M underscore dot is equals to Wt divided by H1 minus H2. Okay, we will calculate it. So here comes the M dot 9013. Now we will calculate the heat in the system. So we will mention this at heat in. The formula for it will be Q in is equals to the mass flow rate which we have calculated. So M underscore dot, and it will be multiplied with the H2 minus H2 minus H4. We'll add the multiplication sign over here. Okay, so here's come the Q in 6.35 into 10 to the power 6. Now finally we will have to calculate the efficiency of the total system. We will write it as efficiency of the power plant. Okay, we will mention that eta underscore t as it is a total efficiency, which will be equal to the given work done, which is Wt divided by the Q in, which we have calculated, and here it is 0.03 03074, which is 3.74%. So this was the EES video. I hope you understand it. So do like this video and share your thought in the comment section. And that's it for today. Thank you so much for the face.